testing. Hello everyone, I'm Professor Manisha Kapoor. Welcome to our session on hypothesis testing. In this section, we will learn how to perform one of the fundamental tests in statistics, that is hypothesis testing. Hypothesis testing is at the heart of decision making. In this topic, you will learn how to formulate hypotheses and take decisions according to the result. Hope you remember this slide from my lecture on estimation where I talked about confidence interval. Confidence intervals provide us an estimation of where the parameters are located. However, when you are making a decision, you need a yes or no answer, and hence we use a test. Hypothesis testing gives us a concrete boundary to decide. Hypothesis. A hypothesis is an idea that can be tested. In other words, it's a premise or claim that we want to test or to investigate. Here, investigate means we take a survey of 200 to 300 people, ask people, get some data, and we can use that to study the population. So when we talk about investigating a claim or testing a claim, we are talking about doing sampling and getting the information and then testing the hypothesis. So much like in science, you have an idea and you want to test it. For example, my hypothesis is people who survived from coronavirus are those who used to drink apple cider vinegar at least 5 days in a week. That's my hypothesis and I have to test it. So in the statistics, we will be coming out with tests that we need to perform to investigate some sort of hypothesis. Half the challenge is when you are going through the problem, you have to pick up the hypothesis by understanding what they are actually interested in studying, and then you figure out the test that you need to do. Let's understand more about hypothesis. If I say apartments in New Delhi are expensive, then it is an idea or a statement, but is not a hypothesis. It is not testable until I have something to compare it with. For instance, if I define expensive as any price higher than rupees 30,000 square feet, it immediately becomes a hypothesis. There are two types of hypothesis: null, which we denote by H naught, and alternative hypothesis, which we denote by H1 or HA. Null hypothesis is a default hypothesis. It is a case of status quo, something which is normally happening, the present state of affairs, or things which is established, no change situation. For example, when we are studying the parameter of population such as population mean weight, we will have some currently established things such as the mean weight of adult human is between 60 to 90 kgs. So we'll call it H naught as it is currently accepted hypothesis. But if some new information comes and a researcher wants to challenge that null hypothesis with his new information or premise, we call this new premise as alternative hypothesis. It is denoted by H1 or HA. This alternate hypothesis is something which we propose is true and we are currently testing it. It is also called research hypothesis and involves the claims to be tested. Let's understand this with an example from today's situation. It is currently accepted that people who exercise live longer, but tomorrow, if I come with new information that is not exercise but entirely a person's genetic structure that determines longevity, so we test our alternate hypothesis by doing some tests and finds is to be correct. So there is always some null hypothesis, something that everyone currently think is true based on previous survey or previous set of data. But then somebody comes with a new information, call it alternative hypothesis or research hypothesis, because that's what we have to test. It is what you are generally researching on. Let's try to understand the difference between null and alternative hypothesis through this example. The statistics department installed energy efficient lights, heaters and air conditioners last year. The previous average monthly energy usage was 3,124 kilowatt hours. An engineer claims that after installing energy efficient lights, the average monthly energy usage has decreased. write H0 and HA. We write our null hypothesis in terms of H0, which is equal to 3124 kilowatt hours. It means that the mean average usage is 3124 kilowatt hours. This is our null hypothesis because it is currently what is happening. This is the default position that everyone thinks, that the usage is same as it is and there is no change. It is a number which is currently accepted. But now an engineer claims that because of energy efficient equipments, that is by using energy efficient lights, heaters and air conditioners, the energy consumption has gone down and that it is not what we were previously consuming. So our HA, that is alternate hypothesis, becomes that the mean average consumption is not equal to 3124 kilowatt hours. It is important to note here that our alternate and null hypotheses are always going to be mathematical opposites of each other. The concept of null hypothesis is similar to innocent unless proven guilty. We assume innocence until we have enough evidence to prove that a suspect is guilty. When you are accused of crime, you are presumed to be innocent. Whenever someone is prosecuting for theft, the court is going to accept that you are innocent, and it is up to the lawyers and the evidence to prove that you are guilty. If they can't prove that, then we go back to default or the null hypothesis, which is that you are innocent. We presume that it is the case unless the evidence proves it to reject it. So what are the possible outcomes of the test? There are two things that can happen, and in statistics there is a very specific way to state that. The two outcomes can be either you reject H0, that is your null hypothesis, or you fail to reject null hypothesis. You don't have to prove innocence in statistics. You don't have to prove null hypothesis is true. So you either reject null hypothesis or fail to reject null hypothesis. We don't say either of it is true. We say we don't have enough evidence to support it. In case we reject null hypothesis, we are promoting our alternate hypothesis to be true. We are saying that this is the case based on the current data that we have. Let's check one more example. I want to check if the apartments in Delhi are expensive. That is, the prices are greater than rupees 30,000 per square feet, as I define expensive as any price higher than rupees 30,000 per square feet. Please note that currently it is assumed that the apartments are not expensive. So the null hypothesis here will be opposite of the statement I want to check. Since I want to check whether the prices are greater than rupees 30,000 per square feet, we'll state our null hypothesis as the average mean price is less than or equal to rupees 30,000 per square feet. And since we know the alternate hypothesis is opposite of null hypothesis and will cover everything else other than null hypothesis, our alternate hypothesis becomes that the mean prices are greater than rupees 30,000 per square feet. In next class, we'll discuss about test statistic and when and how do you decide to reject it.